Alright, so a quick aside, which is not a quick aside really. I've been shopping and bought some stuff. This is all low voltage stuff, not stuff I'm normally used to dealing with. I never check this, I hope this is right. 15015, 150 milliamp. Okay, so what are we building? Two things really. First thing we need is a 15 volt power supply, and so I'm going to start with that because that's actually a really handy thing to have if you're doing audio circuitry. If you're playing with op amps, most op amps require a positive and negative rail supply, and I'm going to use a fairly traditional linear regulator in both rails. So we've got a 7815 as a positive regulator. Now in this TO220 package that'll do about an amp. Probably wouldn't try and pull an amp through it without a heatsink of some sort. We're not going to pull anything like that. In this particular instance, this power supply is to power the second part of the project, which I'll do separately, and that's an RIAA preamp. So the jukebox is going to need a complete overhaul of its audio circuitry, and we're going to start with what we need to start with, which is a preamp. And the preamp has to have, well, it doesn't have to have, the preamp is going to have RIAA equalization. Tweeties. No bud this time, just Tweety birds. So they are in the roller door behind me, so they're going to chirp every now and then. Every time Mummy shows up with a bit of a snack for them, they go a bit nuts. Alright, so for a positive and negative power supply, alright, so this is a pretty standard bridge rectifier application, feeding the two rails in and using the center tap as ground, positive and negative out. And what we're going to do then is basically feed this into basically a pi filter, quite similar to what you'd expect to see almost in a valve circuit. Then 7815 regulator and back out. And that's basically it. What we are going to do is put a decoupling cap, which needs, and I'm going to draw that really close to the 7815, because if you read the data sheet for these, that decoupling cap does need to be really resisting the urge to do a big loud shush there. I don't want to upset Mum. If she sees me looking, she flies in and then flies straight back out again with the food still in her mouth, so I'm just trying to keep out of her way and let her do her thing. Hopefully the babies grow up and fly away soon, because it's been pouring with rain for 3 or 4 days here. I can't close the garage door. The rain doesn't come in. The garage doors are situated pretty much in the only direction that wind doesn't really blow from here. But just the damp from all the rain we've had, because it's the height of summer and nearly Christmas, and that's, you know, what would you expect but pouring rain for days on end. Anyway, now I'll probably put another decoupling cap here. That one doesn't need to be as much. Let's call that 100 mic. Something like that. And that should give us a really nice clean 15 volt output. And then the negative rail is basically the same thing, but we use a 7915. The one thing you really got to be careful of is that on a 7815, and I can't remember which is which, that's the 7815 there, the pins are in, ground and out, which makes perfect sense. That's, to my brain, that's perfectly logical. That one, I can't remember what the pin out is off the top of my head, but I know that the 7.9 series are not in, ground out, so just be aware of that. Don't assume that they're both the same, because they are not. Okay, so that's what we're going to build. We're going to build it on stuff I've been building electronic circuits on since I was just a little boy. This has been around forever. If you haven't seen it before, it's Veriboard, and it's basically just nice strips of copper with properly spaced holes. This is what we're going to build it on because, like I say, it's a proof of concept. It doesn't really matter, and even though this is a prototype, I probably won't actually ever get around to making it any better than this because it probably just doesn't need to be. So we're going to have the transformer will be set off to the side. That's going to get bolted into the chassis somewhere, and it's my plan, we'll see how that goes, that if this works nicely and I can find a decent amp, or if those hybrid modules that are already in the amp work fine, then this and the preamp will get mounted inside that chassis. Now the preamp may need to be shielded, I'm not sure. We'll see how we go with that. At this stage it is my plan basically just to mount the power supply and the preamp inside where that existing circuit board is. It'll be perfectly adequate for my purposes. I just want a jukebox that plays because I like the idea of having one. Right, there's no real rhyme nor reason to it. I don't need one. I don't have a pub yet. I probably don't want a pub yet. So, at this stage, what I normally do with Veriboard, and I'll try and do a better job than I did in the very unlikely event, Terry Thomas, that you're watching this. I apologise. I used to work for Terry many years ago when I was still at high school. And I did a project for him where I basically had to build something that was, from memory, some kind of phone answering system. And it used the incoming ring to charge up a capacitor. And if you watched it on a scope, you could see it sort of bouncing up as each ring came in. And he designed the circuit. He's a very talented man. Designed the circuit, gave it to me and said, build this. And I said, I'll build it on some Veriboard. And he said no. And I can't remember what he wanted me to do, whether he wanted me to design a circuit board for it or what it was. He said, no, do it properly. And I was full of youthful exuberance and confidence in myself. I said, no, Terry, I can do it on Veriboard. I've built heaps of stuff on Veriboard. I know what I'm doing. I'm confident I can do it. And you probably see where this is going. It did not work. Turned out I'd missed a jumper, some part of the circuit that was supposed to be connected to ground that I hadn't done. It was something obvious, but I remember it pissed Terry off at the time because I had sworn black and blue that this was the way to do it. It was not. Well, it probably was, but maybe I just wasn't as clever as I think I was. Anyway, here's hoping I'm a bit cleverer now. Let's assume that's our 7815. So that's in, ground and out. If I break the track there, I can pretty much just run that the way it is right there. I don't actually need the input here, and I don't actually need the output here, so I may kink the in and out legs to just go based over into the right spot. That will actually save me having to straighten the legs on this, and it'll actually just make things a wee bit neater, I think. Now, if you're watching this and going, "You moron!" please yell it louder, because I'm clearly not listening. But I think this will work. I will have a quick double check. I think that's our whack. Have a look. What do you think? Will it work? Okay, is that going to work? I think that's going to work. Put our input from the negative side of the diodes into negative side of these, because this point here is 0 volts. So positive, negative, positive, negative. This is our negative 15 through the pi filter. This is overkill. Thanks, Mummy. Yeah, this is overkill. Really, for what we're doing. Necessary? No. We should probably have some protection diodes in here as well. I may add those in. You sometimes see protection diodes across the regulator, and then reverse protection diodes on the output as well. I may add those in, I'm not 100% sure yet. So, first diode, I'm going to leave a couple of holes. I'm actually going to leave maybe a bit more than that, because I may want to drill a hole here for mounting. So I'm going to leave 4 holes blank, then a couple of holes for mounting the wires into. We're going across 1, 2, 3, 4, 5 blank holes. So if we leave a couple of tracks at the top, just for spacing, maybe leave 1 track at the top. I'll leave 4 holes for there, 2 holes for that. So the first diode is going to go from there. It's going to go across 1, 2, 3, 4, 5 holes and go to there. So that's our first diode. The one beside it is going to go 1 hole shorter. And then we're going to go there, and it's going to go 1, 2, 3, 4, 5. 5 to there, and then this one to there. Okay. I like to do this reasonably neatly. Is it necessary? No. And we're doing it anyway. Bloody oath. Alright, so we got one AC input here, where we're attaching to the cathode of one diode and the anode of the other. One AC input here, where we're doing the same on those two. Leaving a decent gap here. The enemy of these, the main enemy of these, aside from age, is heat. And so if this is going to get warm, you don't want to jam these up against this, where that heat can actually really take hold and start strangling it. Right, pretty happy with that just for the moment, so let's just stop. clean the tip. You don't want to stick it in without cleaning the tip. So yeah, my job with Terry Thomas Electronics in Dunedin. That was an interesting job, that one. He was a marine electronics specialist, and my dad was a commercial fishing skipper, so that sort of gelled nicely. I think that's where the connection came from. And the other thing he used to do was build battery charging power supplies for caravans. So one of the caravan manufacturers he made power supplies for, and we used to have to make runs of them. And they had big ass capacitors in them, big electrolytics, like decent chunky, you know, you'd hold it in your hand like a cup of coffee type electrolytics. And I built up a run of these, had them all lined up on the bench. That took quite a while to put together. I built up this run of them and then was testing them, going along just testing all the outputs, and I think the output, pretty sure they had to charge batteries as well as operate as a power supply, so I think they were probably around 14.5 volts at the output. Running along checking them all, and one of them had no output. I thought, that's weird, and I was just about to stick my head over the top of it to look and see if I could see anything wrong, when there was this earth-shattering kaboom, and then this geyser, and these are big oil-filled caps with a big vent plug on them, and I had connected it backwards, and it had sat there calmly on the exterior, but no doubt seething underneath. It sat there this whole time I'd been going along testing all the other ones, and it was just as I was about to stick my head over the top of it, and it let go, and this plug embedded itself in the roof. An earth-shattering kaboom that brought everyone else in the building running through to see what was happening. And we shared the building with, I think it was Anderson Sound, who all their techs came running through, saw what had happened, immediately worked out what I'd done, and just they were all pissing themselves laughing. They thought it was a great joke. And Terry came out of his office, and he just had this absolute forlorn look on his face. And he said, "Do you know how much those capacitors cost?" And I had a fake idea how much they cost. They were not cheap. And he just said, "Fix it, get it sorted," and he turned around and walked off, and I felt really, really bad. I'm sure the pittance that I was being paid, it probably would have taken me a week away just to pay for the darn thing, but yeah, these are the lessons you learn along the way, right? I pretty much had to go and change my undies, so it was a fairly scarifying event for me. Everyone next door thought it was absolutely hilarious, and yeah, they didn't have to face the boss. I felt pretty stink over that. Yeah, one of those things you remember, right? So, anyway, where are we going? We need 10 nanofarad. 22 is going to go here. Now, the other thing that's going to get hot in here, depending on the voltage, the more voltage these have to drop, the hotter they get. As well as, clearly, the more current they pull, the hotter they get. But you probably don't want to drop any more than about 4 or 5 volts with one of these. If you start dropping huge voltages, these have to work really hard and they just get hot all the time. Right, so this I want to tweak the legs. Alright, something like that. And Alright, that'll do. How many people were watching that and going, "You idiot!" Because I missed it. I don't even know why I thought that was the right place to put the holes. I don't even know if I looked. We need the plus 15 to be on the output of the regulator, and I put it right in the middle. And it wasn't till I looked at this link here and went, that's bridging 1, 2, 3, 4 tracks, bend it up for that, and then it wouldn't fit. If I hadn't done that, well, if I hadn't done that, I wouldn't be putting this in, so it's kind of a catch-22. I dumbed out if I did, or I dumbed out if I didn't. Now, what I've also done is just significantly weaken there. So when I go to break this board off, I'm going to have to be really careful that it doesn't break right there. Yeah, that's more than a little frustrating to have made such a stupid mistake. But it happens. Alright, there's still something not right here, because that still doesn't fit. Let me just double check that I haven't done something really stupid yet again. I have done something stupid, haven't I? Nobody thought to stop me. Come on guys, help a fella out. Alright, this is a 7812, 7815 rather, 15 volt rig. The pins are input, ground, output. That bottom pin is a positive output pin. The middle pin is ground. So I've put this cap around the wrong way. I've put the negative on the output. So this cap needs turned around. 10 nands of course are not polarized, so that doesn't matter. These ones are around the right way because the negative pin's on the ground pin. But yeah, that's around the wrong way, which means this is all wrong. And the funny thing is, I've drawn it right there. I just put it, I made it look neat when I put it in by putting all the negatives in the right place, but that is completely wrong, which means this is completely wrong again. Oh, I'm an idiot. So remember that story I told you about screwing up with Veriboard? Seems I haven't learned a goddamn thing. Decades later, still screwing up with Veriboard. I even drew myself a pretty picture, I just ignored it. So, believe it or not, I've got to drill one more hole. What are the odds I've got it wrong again? Pretty damn good at this point. And this is turning into a big mess. I've just thrown out my rubbish bag and haven't replaced it. I'm just going to go and sit down and double check my work at this point. If you're playing along at home, feel free to double check it yourself. I'll be back shortly to determine whether I have to start again. Idiot. Alright, so we are done. I think. I hope. We'll see. Anyway, I've hooked up the transformer. That is just hooked up temporarily to a mains cord. Do I recommend you do it? No, but you do you. Mains is dangerous. Play with it at your own, blah, blah, blah. You know the drill. We've got our 30 volts center tapped being fed into the correct spot on the board. I checked that. So what we're going to do now is plug it in. Standing back, waiting for explosions. There won't be any explosions. Let's check the positive 15 volts. Boom. 15.17. Happy with that. Negative 15.33. Happy with that. And by the same token, we should have 30 volts across. Yep, 30.5. So, 'tis working. That took way longer than it should have. Partly because of filming, partly because of not braining. But there we have it. Anyway, look, thanks for watching, and I'll catch you next time.